So hi everyone, welcome or welcome back. So today we have Ned Webster, and the talk title is Data Quality with LV's InputChecker. So a little bit of intro about Ned. So Ned is a senior data scientist at LV, and he has experience in building and implementing predictive model across a wide array of business area. So please welcome Ned.
Cool. Okay. Thanks for coming, everyone. I hope you're having a good start to the Data Science Festival. I certainly am. It's my first time doing one. Not just speaking, but being at one full stop, so it's pretty exciting for me. And as I'm sure you're aware, I'm going to be chatting to you folks today a little bit about data quality, which I will admit, it's not the most thrilling or eye-catching topic, but it's super, super important. And the thing I want you to sort of think about as I go through the chat is we're talking about data quality when we're looking at live production of models. So that's the kind of framework that we're going through this talk in. I know I was just giving a little introduction, but before we get into the talk, I'll give a little bit more info about me. So yep, my name's Ned Webster. I'm a senior data scientist at LV. I've been at LV for just over 3 years now, most of that in the data science team. Which is only about, I think it's just over 4 years old now. So yeah, I've been there from pretty early on, and we've grown massively, which is fantastic. I think these numbers are actually a touch out of date. I think we're actually just hit 50 people in the team now, maybe. Yeah, and back when I joined, we were like 10, maybe. So yeah, massive growth, which is amazing because it means that we can do more work, basically. So we've got about 20 models live now, more than that, I think, and loads more kind of on the back burner. Yeah, so the more hands we can get, the better. The data science team works pretty cool in LV, so rather than having a kind of specific data science function for each business area, we kind of work as a central hub, almost like a kind of internal consultancy, and we kind of spread out and reach out to all the different business areas, be it claims, fraud, pricing, you name it, which is brilliant for us. It means that we're not kind of limited to one set of problems. We can solve any data science problems that come up all across the business, which gives us a lot of variety and sort of different data sets to work with. Yeah, which is great. I've popped up the LV LinkedIn page there as well as the careers Twitter. We are recruiting in the data science team pretty actively, from anything from grad assessment days all the way up to some more senior positions. I've also put our LVGI data science GitHub page up there, which houses all of our open source packages, one of which is what I'm going to be chatting to you folks about today, which is InputChecker. For anyone that doesn't really know much about LV, a little bit more info about us as a company. We are an insurance company. I think we're the 3rd largest general insurer in the UK. So the main thing we are concerned with is motor insurance, but we also do home and pet and travel and a few other little bits and bobs like that. We pride ourselves on being kind of the UK's best loved insurer, and we've got a couple of awards to back that up. And we have a team of over 4,000 people, so we're not small. And we reach over 7 million customers, which is really interesting. If you're someone that works in the data space, this should be exciting to you. 7 million customers, that's a lot of data, gives us loads of scope and remit to kind of get our hands involved in different projects across the business. And there's plenty to solve. So yeah, that's a little bit of an intro about me and the data science team. I think it was mentioned by my colleague that we have a stall here, that way, I think, if you come out the door. Yeah, please go check us out. Plenty of our team here today to talk about either the company or the problems we solve. But in terms of what I'm going to be talking to you folks about, yep, data quality. So a little bit of an outline of the talk. I'm going to start with kind of fine-tuning the definition of data quality. It's a pretty broad topic. It can cover a load of things, and it can kind of be as narrow as you want it to be. So I'm just going to give a bit of a better definition of what we mean in the data science team at LV. Bit of a motivation about why we got interested in it and why it was a necessity for us to look at. So we'll build up that, tell you a little bit about our deployment process, have a bit of a chat about what else exists, because we're not the only people concerned with data quality, not by any stretch of the imagination. So there's definitely tools out there, and we'll go over some pros and cons of those and why we ultimately didn't think they were quite fit for purpose. And then I'll actually get on to InputChecker itself, give a little bit of chat about the package, how it works, and then we should have some time for questions, hopefully, depending on how timing goes. So what do we mean by data quality? So like I said, we're talking about data quality in production for machine learning. So it all starts with we've got some raw data. Now this might be your training data set locally on your machine, or it might be some out-of-time data set that you're evaluating your model on, or it could be some JSON message coming from some service hitting your deployed model. But essentially we have some bit of data, and we don't know much about it, but we certainly have some requirements about that data. We need it to look a certain way. We're going to have some features that our model is built on, and they're going to need to be there, and there's going to be some requirements on those data points. So how do we do this? How do we ensure that this data is going to be what we want it to be? Well, essentially, we need to build some checklist of rules, right? Some sort of data blueprint or data schema that we can then check against our rules and our data set and make sure everything looks okay. And this can be super flexible. This can vary massively. It might be that all we care about is the file type, and we say, okay, we just want it to be, I don't know, a CSV, for example, and that's okay. Or it could be as rigorous as checking the individual data points themselves and making sure that they are some exact values. No, that would be kind of the other end of the extreme, and you can kind of go everywhere in between. When we're talking about data quality, we're going to have a bit of variety if we're looking at either batch or real-time processes. If we have a think about what we can check for, let's say, some numeric variable, in batch process, we can check lots of things. We can check, we can look at the mean of some column, some numeric column, and we can say, hey, we want this to be within some range, perhaps. But if we're looking at some real-time solution where we're just getting a single observation at a time, that's not possible anymore. We lose scope for that. So we just have to be wary of what's actually possible for us to check at the point that this is going to occur. And once we've decided that, we've got, we know how flexible we want our checks to be. We know the system and the way that works and how we're going to be implementing it. That implementation can actually vary quite a bit. Where do we want the check to happen? Does it happen within the Python environment itself? Is it some external system in the loop? How do we persist these rules? We have these rules about our data. Where do we save them? Are they saved in some, config file that gets loaded and checked, or are they just stored in some, pickle object that can be loaded in the Python environment? But ultimately, we have these rules, and we can send data through them, and we're going to get one or two outcomes. We're either going to get a green light, and everything's going to be okay, and our process says, yep, we're cool with that data, and it can go forwards, or it's going to get rejected. Some rule is going to get flagged. And there's kind of two main benefits for doing this. One falls in each work stream here. So if we look at, well, what happens if our data gets approved and it goes through? Why do we care? Why is that important? Well, when we build our machine learning models, we're going to have some subset of features that our model is trained on. And for those features, we're going to have some subspace of those feature values that we're happy with. Our model understands it. It knows what to do with them. And we can be confident in the predictions in that space. But then when our features start to move outside of that space, depending on which modeling algorithm we've chosen, different things can happen. We might have some linear model that's going to try and extrapolate some information about it, or we might have some tree-based model that's just going to perhaps cap it at a top bucket. And we're not always going to be happy with the way that these are going to get handled. So in some cases that might be okay, and we can make those adjustments. But in other cases, we might want to flag that. But ultimately, it ensures confidence in our predictions, which is really important, especially when we're deploying models in areas with perhaps non-technical stakeholders that need us to be able to kind of portray that confidence and understanding of what our models are doing. And then if we look at the other side of the spectrum, we've got, well, okay, what happens if some data point gets rejected? It doesn't like one of the rules, for example. Well, in the system, most of the time, even without some data quality check, if something's not right in the data, it's going to raise some error at some point. The problem is that can be any sort of error. It can be pretty hard to debug. It's a bit kind of ambiguous. If we have a specific tool that's going to catch these, we can make those errors bespoke and very informative, and that's just going to really simplify any debugging that we have to do with other members of the team, the deployment team or whatever. So it's really important. It's kind of just a ease of life thing. So a bit of a trivial example here, but let's say we've got some data set. We've got customer ID, their age, and maybe country of residence, and we want to build some machine learning model of this data set. What are some things that we might want to check? So like I said before, we're going to want to check the column names and make sure that they exist. These will be our features in the model, and it's quite important that they're going to be there. We might want to check data types. This is kind of trivially obvious if we're going to get sent some string value when really that needs to be numeric. But also, perhaps there's some nuance in our pre-processing pipeline that's going to expect a float, and if it comes through as an integer, something's, perhaps that might be fragile in some sense, and we need to check that. I've added numeric ranges there as well. That would be something that we probably want to check, particularly if you're looking at something like age. Just because it comes through as an integer, let's say that comes through as some negative value, that's not going to be okay. And then for any categorical features, we might have some subset of unique values that our pre-processing pipeline knows how to handle, and we're happy for those to go forward. And once we have those rules in place, any new value that comes through, some new observation, we can check it against those rules, and as you can see in this example, perhaps this would get flagged here because -10 isn't going to be a valid number for an age. So that's sort of what we're talking about. That's what we mean when we're discussing data quality from that machine learning point of view. So a little bit of motivation about our specific problem. So I've got a kind of overly simplified diagram of our deployment structure. But essentially what we've got here is on the left-hand side, we've got some service. This could be a service anywhere in the business, but essentially it is looking to call our model on the right-hand side, which is some productionized model deployed in the cloud as a REST API, sat there waiting to receive some information. So that service is going to send something at the model, some set of features with some values, typically as some JSON message. Our model is going to take that. It's going to pre-process those features. It's going to score those features through the model, generate some predictions, and then return those into the system. And the system can take those back then through the rest of the process and ultimately end at a decision for the customer. Maybe a insurance premium or something. So there's a couple of things that we can think about when we look at this and we want to add data quality checking to this process. The first and most important one is, well, where is that going to sit? We could have that done by the system. We could have it done by our API in the cloud, or we could have, perhaps we might want to implement some additional middleman step that's going to do that data quality prior to it reaching our model. Our solution ultimately ended up with the development of a Python package that sits within the API that is deployed. And there's one main reason for that, really, is that this system on the left-hand side might be making calls to multiple different models that all require different input messages, different feature sets, different ideas of how those features should look. So we really want that data quality check, however, to be unique to the model itself that it's looking at. So it just kind of makes sense to have that put in with the API, because this message coming from the service could be some generic message with hundreds of features, and we only really want to care about the ones that are in the model. So that's what we did. We decided to isolate that data quality checking to be within the API. So when we're looking at that, we were having a little bit of a think and saying, okay, well, what other solutions are there? There has to be other things out there that we can just use and plug in. So we started having a bit of a browse. And the first one that we came up with was PyDQ. I'm sure Apache Spark is not a new name to any of you in the room. But essentially what PyDQ is it's a kind of unit testing framework for Apache Spark using the PySpark implementation. But there's a bit of a problem with this. I mean, the first problem is that our deployment isn't using Spark, and that would have been a big overhaul. But when we think about, well, what is Spark? We're mainly concerned with kind of big data solutions when it's coming to Spark. We're not looking at some deployed model with a single record being processed at a time. It didn't seem worth it to make that big change over to Spark. So PyDQ was out. Weren't going to use that, and we kind of moved on to, okay, what else is there? Great Expectations was another one that we came across. I'm a big fan of Great Expectations as a package. I think it's a fantastic tool. Again, it's another data quality checking tool. It's got an extremely exhaustive list of data checks that you can do. You can pretty much check whatever you would want. And it's got a fantastic interface to do it. It's really, honestly, it's really lovely to use as a user. It kind of generates these automated notebooks that kind of guide you through the process, setting up your checkpoints. It gives you great visualizations for what it is your data's doing. So this is all brilliant. The caveat is when you build a tool that kind of has that much going for it, you add a little bit of weight from a performance side of things. So small bit of spoiler alert about InputChecker there. Obviously, when we looked at Great Expectations, we didn't have a tool, so we weren't able to benchmark it against anything. But kind of post hoc looking at it, we did some performance tests looking at how long it took to data check a single row of a data frame. And Great Expectations came up as a little too time consuming for our needs. So I'm not sure if you can see it on there, but that's coming up at about 0.3 of a second to kind of give some framework behind that timing. So within the LV data science team, we usually look at a 1 second response time as the absolute maximum. A lot of our deployments are much, much quicker than that, but that's the sort of checkpoint where we would say cannot be longer than that. So 0.3 of a second isn't too long, but if you think about it, this is before we've done any pre-processing. This is before it's even been seen by our model. So we kind of came to the conclusion that I think we can build something that is a little more fit for purpose for what we're trying to do. Because I want to be really clear here. This isn't me up here ragging on Great Expectations. The tool is fantastic. It's just, it's built for a very different purpose. It's a tool that you should definitely look at for big batch data loads and data quality checking in that sort of framework. It's just not totally suitable for the live deployment. So we moved on from that. And kind of next in the firing line was Marshmallow, which is another tool we came across. So for any of you that don't know Marshmallow, I imagine it might be maybe a little less well known. Marshmallow is essentially a tool for serializing and deserializing Python objects. But within that framework, we can build Marshmallow schemas that are going to look at dictionaries, which are what our JSON messages are going to come into our Python environment as. And we can build up schemas that check kind of exactly what we're after checking. We're going to be able to check column names. We're going to be able to check data types. We're going to be able to check value ranges, whether the column is nullable. Can it have missing values in it? So on the face of it, this looks like exactly what we want. This is just what we wanted. And in actuality, we use both. We use Marshmallow in all of our deployments, but we use it alongside our own InputChecker tool. So why is that necessary? Why did we think it was worthwhile having both? A little bit of a flow diagram here that is going to kind of walk through that process. So what happens to data when it hits one of our deployments? So, like I've said, we have some raw JSON message with our features, and it gets fired at our API. And the first thing it's going to do is it's going to come into our Python environment as a dictionary, and it's going to hit Marshmallow as a kind of first blocker. And Marshmallow is just going to run its checks. It's going to make sure that everything looks as it should. And then if it passes all those, it gets the green light. It's going to keep on plowing through to kind of the next phase. So next up, you have to convert it to a data frame in order for it to go through our pre-processing pipeline and be able to be scored by our model. And it's going to go through this other step that we label as sort of production data fixes. And this is a really important point to kind of mention when it comes to live deployment of models. There's an unfortunate reality that when we build our models, we have some local training data set, some CSV perhaps, that has been collected for us. And unfortunately, this doesn't always line up one-to-one with how that data looks raw in the service. There might be some small discrepancies, and these are oftentimes as small as column names just aren't quite what they're supposed to be. They don't line up perfectly. Perhaps during the data load by the BI team, something's been changed. So we fix those, and they're not big fixes, absolutely not, or we'd like to think that in most cases they're not going to be big fixes. However, they are unchecked by Marshmallow. And then once we've done that, it's then ready to go through InputChecker. So if you're looking at where does InputChecker sit and what's its remit, I suppose, as a data quality checking tool, it is very much focused purely on the pre-processing pipeline and modeling. So the idea is that if your data passes your InputChecker checks, you are ready to go through your pre-processing pipeline and get model predictions out, and you will get model predictions out that you are confident in. So that's sort of the main reason, is that there's these kind of untracked checks here, but there's another small point that's worth highlighting when we're talking about Marshmallow versus InputChecker here, and that is drawing a line between what is acceptable data from our model's point of view and what is acceptable data from a business service point of view. So what do I mean by that? Well, this raw JSON message is coming from some system within the business, and they might have their own idea of what are acceptable values for that message. And they will quite often line up with what we want in our model, but not always. There can be discrepancies there. So we will work with the business areas to define this JSON message as best as we can, but ultimately it's sort of up to them on what they're going to send us. So there can be some discrepancies there. A good example of this, as we saw in the little demo a few slides back, is age, for example. That might be a totally acceptable integer for our service to be sending, but if we're looking at some insurance premium model, ideally anything below the age of 17, that shouldn't be around, because, I mean, you can't be going and getting insurance policies at that age. So that's the sort of difference we might be recognizing at this point. And like I said, once we're through both these checks, we're happy, and the data can flow through the rest of the process, generate some predictions, return it back to the service, and lead to some outcome for the customer. So that's how we use Marshmallow, and some of the pros and cons about the other solutions that are out there. So at this point, I appreciate we've spoken a little bit about InputChecker kind of vaguely there, but at this point we didn't actually have the tool. However, we had a really good idea of what we wanted that tool to be and where it fit in our deployment process. So we had a few requirements. So here's some buzzwords up there for you. First one is it needed to be streamlined. So we had a current deployment process. It worked. We liked it. And we really needed it to kind of fit pretty seamlessly into that. We didn't really want to shake up our whole deployment. So that was a pretty big requirement. It needed to be lightweight. We saw this with Great Expectations. Low call speeds was really, really important, especially when we're looking at some of the APIs we've deployed recently that kind of sit on the broker side of the business. Essentially, they get taxed very heavily in the number of calls they receive per minute. So a really quick solution was necessary. I've put low memory consumption up there. This actually wasn't something that we really had to concern ourselves with. However, if you're out there as a team, it might be something that is worth considering when you're looking at what your solution is going to be. It might guide you in some scenarios. And then it needed to be flexible as well. So we deploy our models, and we have some saved set of rules for that data, but we're very aware that these rules can change as data changes over time. A good example from the insurance industry is, as new makes and models of cars come out, we need to have a way to handle those. Simply not returning predictions, because someone has the latest model of some car, it's not really appropriate. So we need to be able to go into these data rules, make adjustments easily without kind of having to bring the whole thing down, modify it in some cumbersome way, and then redeploy. So that was important. So what did we come up with? This is sort of the process flow for our InputChecker object. And it should look familiar to anyone that has built any sort of pipeline using the scikit-learn framework. The scikit-learn pipeline framework is a really clean, neat solution to kind of building pre-processing pipelines and building models. You have this sort of step one during the training, whereby you fit all your pre-processing steps. You know, let's say you have some mean imputer. This step might be, you know, generating the mean value for your columns and persisting those values, and then you train your model. And then you're going to have the scoring or the transform or predict method on the other side, which is going to take your new data and generate predictions. So we really like this solution. We think it's really clean, and we like it so much that we actually built our own package, Tubular, which I'm just going to have a brief mention here, but my colleague Richard actually did one of the workshops 2 weeks ago for the Data Science Festival. If any of you haven't seen that, I would recommend checking it out. But yeah, Tubular is basically a wrapper for the kind of scikit-learn pipeline approach for pre-processing. So yeah, check that out. But essentially, this framework works perfectly with some pre-processing tool, if you think about it. In our training step, we can fit our InputChecker object and learn some rules about our data that can then be referenced when we come to scoring. And it just fits into the pipeline. So we can just tack it on as the first step in that pipeline. So a little bit of an example here. I'm not going to do a live demo, believe it or not. I'm terrified the tech will fail me. But yeah, a little bit of kind of screenshots of some notebooks. But let's say we have some data set. This looks very similar to what I showed earlier in the slide. But you'll see here that in the country column, we might have some missing value. And we want to build some pre-processing pipeline for this data set. So this is what we might come up with. So as you'll see here, I'm using Tubular. I appreciate most of, if not all of you, are not going to be familiar with it. But for anyone that's used scikit-learn pre-processing transformers, it works in the same way. And we can build up this pipeline. So you'll see it there in step 2. It's just some arbitrary imputer. We're going to impute any missing values with the string missing. But you'll see there in step 1, we've got our InputChecker object. So we've got, 2 lines of code. We just define the numerical columns and the categorical columns. This isn't a necessary step, but if you do define these, InputChecker is going to learn a few extra things about those columns, knowing their types. And it's as simple as that. We now have our InputChecker object put in our pre-processing pipeline. And then when we want to come to training our model, we can fit this pipeline as we would any other scikit-learn pipeline. So you'll see that in cell 3 there. It's just being fit, it's learning some things. And then when we go to transform that data, if you see at the bottom there, you'll see the missing value that was previously none has now been replaced with the string missing, just as we wanted it to. And we don't get any warning. Nothing is screamed out at us. No error messages. And this just tells us that InputChecker was happy with this data set going through. But this shouldn't be a surprise. This is the data set that we trained it on. Necessarily, this should work. So what happens then if we take some new observation that we've got here, where we've got an ID, an age, a country, and we want to generate a new prediction for this. Let's say this is some data point that's been sent at our deployed model. And we're going to end up with this error message. And it's super clean, it's super easy to read. It comes through as an InputChecker error. It tells us that it failed the minimum value check. So because we highlighted that age was a numerical column, it's going to take a max and min, and it's going to reference then against new values coming in. And we see that this value is actually below the expected value, and we're not happy with that. So that's the core functionality of it. And if you can imagine, if that's put in some deployed service, it's really helpful because that when we get those errors, we can go and we can look in the logs and we can see what's gone wrong, and we can go back to whoever it is that's in charge of the deployment and say, hey, look, something's not coming through right, and we can debug that much quicker. But there's some additional functionality that we have either recently added or would like to add. So a lot of what I've been talking about is for a single record being sent for some live deployment, but we are deploying some batch models, and it would be nice to be able to have a single solution for batch as well. But a problem we were running into is that, let's say we have some batch of tens of thousands of observations. When we send that through our InputChecker, it only takes one data point to be sort of corrupt for it to break the whole batch down, and everything falls over, and we get no predictions for anything. And that is a real pain, and it's not really how we want the solution to work. We would like to be able to still get predictions for everything that works. So we put this in as an additional feature where we are scoring batch data sets, where it will actually recognize what passes and fails, and it will split those out, and those successful data rows can go on through the rest of the process and get predictions out, so we're not missing any business value, and the failed ones will be flagged in the logs for us to check. The other thing we'd like to implement, this hasn't been implemented yet, but it's in the work stack, is right now our InputChecker object, much like your preprocessing pipeline, is saved to some pickle object, which is great from the Python environment point of view, and it works great for the deployment, but it's not very human readable. If I move on to a project and I want to have a look at how does the data look, this InputChecker object would be a good place to start, but it involves me loading up a Python environment, going in, loading in the object, having a browse through it with some of the APIs. It's not perfect, so we'd like to be able to have that get converted into a JSON message so it's a bit more readable as some sort of config file. And then hopefully sometime in the future be able to actually build InputChecker objects from those JSON files themselves. That would be quite nice. Final point on InputChecker is that the package is open source. I mentioned this. That up there is our LVGI data science GitHub. So it's up on there, so you can go have a little browse through the source code. It's also available on PyPI. So easiest way to get it and start having a play around with it is just pip installing that one. You'll also find our other packages that we've open sourced up on there. So Tubular was one I mentioned, and we've also just released a third one, which is all around a sort of wrapper suite for unit testing. So all of them are quite production focused. So to conclude, why do we care about data quality? The main reason is that it helps us be really confident in our predictions, which is extremely important. You hear the term sort of black box get thrown around a lot, and I think for some non-technical stakeholders, it brings in a bit of worry about, well, does anyone actually know what's going on once these models go into production? And this is a way that helps us convey that message that we are confident in what's going on. It's important to notice that your solution is going to vary depending on what your requirements are for your system. We're aware InputChecker is not going to be suitable for every deployment or every system. It works for us, and we think it's probably going to be useful for a lot of people, just not everyone. It's very focused on live deployment. That's what we built it for. It's lightweight, it's quick, and it's really easy to slot into current preprocessing pipelines. And it's open source. Go try it out. We are open to contributions. There's contributing guidelines up on the package, as well as if you come across any bugs or errors or issues, raise a ticket, and we've got an active group of people in the team kind of maintaining these packages, so we'll look to get that resolved as soon as possible. Finally, I'll just reiterate, we've got a stall, LV as a team. If you want to hear any more about this or about any of the other packages or any of the use cases we work on, or just the company in general, yeah, please go check it out. And I think that was everything I had. So yeah, questions, I guess.
Thank you, Ned. So if there is any question, it's time. So please use your best voice, very loud. We have one.
Hi. Thank you, Ned, for this presentation. One question. So in the first part of the presentation, we saw the comparison between the one another outsourced module and our input checker.
Mm-hmm.
So you said that the main reason we did not took the already built one
Mm-hmm.
was the time it was taking. So I'm just curious about what is the maximum number of data rows that has been
Yeah, I mean, it absolutely is. So for that graph that I showed, that was passing a single row. So when we're talking about a single observation, which is what our data is coming through for 95% of our deployments, times are negligible. It's not going to make a difference. The real weight of deployment time usually comes in the pre-processing, unless you've built some extremely complex technical model, which is why it was a concern if we were going to have a lot of heavy weight on our data quality checking. We kind of need that time reserved for pre-processing. That's kind of where the heavy lifting happens. So yeah, for a single row, it's completely negligible. I don't have figures for our batch process, but the solution works. Yeah, it's suitable. Typically, batch processes they don't fall under the same constraint, time constraints. Because if you think about a single observation, let's say you're on lv.com and you want to get a premium, there's a certain amount of time you're going to be happy to wait until you get your price returned to you. You don't really have those situations in batch scoring. They're usually done offline.
And if I understood correctly, the pickling file
Mhm.
that acts as a sort of input to the input checker when we are running or importing that module.
So the pickle file is sort of the serialized version of your input checker. So it could be saved and persisted. So when we deploy our models, there's sort of a initializing or setup that's done. And one of the things that will do is it will load in all of your artifacts. So that's your model, your pre-processing pipeline, and your input checker object. And they will be sort of set and primed, ready to go for when things start getting fired at it.
Okay, and the rules that we are sort of giving to this input checker,
Mhm.
like you just mentioned in the example, that age if is less than a certain
Mhm,
number,
mhm.
in this case 10, is not acceptable. So is that according to the pipeline that we are passing it through, or we can modify the checks?
Yeah, so natively, they're implicitly defined from your training data set. That's how they're built originally, but that kind of goes back to the point of this object having to be flexible. There are scenarios where your training data set isn't going to cover everything you want, and you might want to make adjustments to those rules, which is why we included methods and processes for manually overriding some of these rules. Yep. No, welcome. Mhm. In terms of, okay, so when we save the input checker, it is saved as a single artifact. The stakeholders won't have access to that, but when we're scoping the project and when we're during our analysis phase, we have a lot of interaction with stakeholders and sort of business area expertise to make sure that the data is looking as it should in our training data set. And they obviously have a great understanding of their own data. So naturally, we don't really run into issues like that, because if our input checker is going to throw a problem, if we know it as a data science team, they're going to know it as the business area expertise. And that's sort of how we get around that. Did that answer the question? Or? Okay, perfect. No, yeah, okay, so I'll actually grab onto that. It's a really important question. So when we're scoping our projects, we make sure that for any deployment that we have, we kind of need some fallback solution. And that is going to vary depending on the project. So in some scenarios, it will be that if something goes wrong, it will default to some human interaction, fraud model perhaps. Sometimes it will be just default to whatever the historic solution was prior to any machine learning implementation. And then in some cases, it is just acceptable to not return a prediction. Yeah.
Say if you're given a large data set,
Mhm.
right, and you don't have much of a background of the data set, but you have some background of the data
Mhm.
set. So on what basis do you make these rules or these checks? Do you like make it out of your assumptions to make it more sensible, or to what? Like, how do you set these rules?
Yeah, so like so the rules are set purely from the training data set, bar any adjustments we make at a later point. it kind of raises the point that during the kind of EDA and data analysis phase, you should be checking your data to make sure that it looks reasonable. And any questions you might have about that data, you should be consulting with stakeholders and business area expertise to say, hey, I don't know the data as well as you, but something here doesn't quite look right. Can you confirm that this is okay or not? And if there's an issue in your training data set, then yes, your rules will be incorrect per se, but the idea is that you would catch it prior to building the InputChecker object.
So say if we don't get any information back when we head, like just leave out that particular set of data, or do we make our own assumption?
So if we were in a scenario where we weren't able to get any input from stakeholders around whether the data was okay, first of all, that would be a bit of a worrying scenario. I don't know if I'd be happy with that. But yeah, we will make assumptions. We can work with the training data as it is, and we can build rules off that, and we would be more conservative in that scenario. So a good example is we would be okay with the training data set, but we wouldn't adjust those rules, and we would be pretty keen on denying anything that didn't come through in that format.
So would you suggest to make like different models? Say if I have certain assumptions and particular models in a set. So do you think it would be more sensible to provide like different scenarios to your assumptions? Some of them could be bad, some of them could be good, some of them could be average assumptions.
When you say models, you're talking about kind of business outcomes for what happens if something fails. Yeah, absolutely. Again, like I don't think I can stress enough when you're deploying models in a live production service, it is not a sole process done by the data science team. We are very much just a cog in that process. Everyone else needs to be involved in that process, and these sorts of things would be discussed during the project scoping and should be outlined so that you have a clear idea of what your deployment is going to look like before you even start it. Yeah. Yeah, yeah, absolutely. I mean, I would say that as much as I love InputChecker, I don't think it would be suitable in a kind of big batch data engineering load. But absolutely, some of these other solutions are great. If you're using PySpark, PyDQ would be a really good option. If you're not, I would recommend Great Expectations as a tool. Okay, and I think, unfortunately, we're all out of time. I will quickly say I will be around or at the stall. If you have questions that I haven't been able to answer, please come and find me and ask.
So thank you, Ned. And I could see some hand raised, and unfortunately, it's coffee break. So, but Ned Boots is at the end. So please go and have a chit chat. So we'll be back here at 11, and the title of our talk will be Data at the Forefront of Cyber Insurance. So please come back. See you at 11. Thank you.